She was the first of the speakers I got to talk to when I first arrived yesterday, and she was telling me about her talk. I'm very excited to learn about what she has to say. She's a Chrome engineer, but her most important task is adding emoji support to Chrome. It's
not working well, guys. It's not working well.
But she's going to be telling us about DNS, which is something we should all understand better than we do. So give a hand for Monica.
So I think Tracy's trolling all of us because she was like, what should you do with developers at 9:30 in the morning? Tell them about DNS. So that's not very good. So I think one of the problems that we have in the JavaScript community is that we spend way too much time looking for cats on the internet rather than at cats on the internet. And this isn't something that we can fix by throwing new libraries or web components at it. I think we need to go to the root of the problem, and that's clearly the root of the internet, and that's the DNS system. So I want to tell you how DNS works, what it is, why you shouldn't be afraid to make eye contact with it. It's not afraid of you. It's actually really simple. I'm from Montreal, from Canada, so I'm here to reinforce, oh, that's me curling. You can clearly tell that. I want to reinforce all Canadian stereotypes here. I say sorry a lot, and I mispronounce it, apparently. And I'll say A couple of times. I work on Chrome, which means I'm actually a C++ developer, so I get very excited when I get to talk about JavaScript, where the compiler isn't permanently disappointed in you, which is the story of my life. It's like my mother. Cool. So let's talk about DNS. Oh, I'm not Waldorf on Twitter and GitHub and all sorts of internet things. Yeah, DNS. So DNS stands for Domain Name System, and it's basically a giant phone book for the internet. Every time you see a human-readable host name, so basically if your brain can parse it, that means it's not a thing. It's not actually a thing that the internet understands. So what a DNS is good for is that it will translate that to an actual IP, like the server under somebody's desk where your resource actually lives. And we call this resolving. This is a word that you're going to hear around a lot. So I wrote a thing called CatDNS, which is also a DNS system, but instead of actually being useful, it resolves everything to cats. It looks like this. So if you try to go to Google.com, you get a cat. It actually redirects you to a static web service that's written in Go by my friend Cat at work. So a man named Cat wrote a cat service. Can we take a moment and appreciate that? And basically, anytime you try to go to any website, you're going to get cats. That's it. That's all it does. It's a DNS system. So let's talk about how this actually works. Oh, but if you try to reload your Twitter feed through an app, you're not going to get anything because Twitter doesn't actually speak cats. It's only the browser that does. It's a thing I've added in Chrome, clearly. So how does this actually work? And if we want to write our own DNS server, we have to figure out two things. How your browser talks to a DNS server, and what sort of magic shenanigans your DNS server does to actually compute this magical IP address. So your browser talks to a DNS server over something called UDP. UDP stands for User Datagram Protocol, and much like TCP/IP, it's an internet protocol, but it's really simple, and it's really easy to explain. Somebody from Reddit recently called it the honey badger of internet protocols, and that's because UDP does not give a shit about anything. It doesn't have any state, so it lives in like this blissful amnesia between messages where everything's exciting and new, and oh my god, somebody's talking to me. It doesn't need to know who you are, so it doesn't do any authenticating, any handshaking, or anything like that. Anybody can talk to a DNS server. And most importantly, this is my personal favorite, it does not care if you receive its message. You're going to ask it something, it's going to tell you something, and if you didn't get the answer, you're just going to have to ask again. Sorry. UDP, guys. Not very Canadian. So the reason why it's actually really great for DNS is that DNS is very chatty. Because as I told you, every time you see a human-readable URL, that's not a thing. That's a thing that the DNS has to take care of it. So if you have any application that has to ping home every second, like your Twitter timeline or your Dropbox account or your Hangouts, all of those need to talk to a DNS server all the time to be like, hey, who am I talking to? Who am I talking to? Any browser any website that you go to. If you go to images.google.com, you're going to have to talk to your DNS for images.google.com and for whatever jQuery you're importing and for every image that you're seeing in there. It's a lot of work. So Google has a public DNS, and it lives at 8888, and it came out around 2012. And the idea here is that most of your DNS actually comes from your internet service provider. So all ISPs have their own DNS, and your router magically knows how to talk to it. But if your ISP is a piece of shit like mine is, the DNS server is actually going to be really terrible and slow. So you might want to use a different one. So 888 is one of them. And in 2012, when it came around, they published some numbers as how this was going. So it was getting something like 800,000 requests a second to a total of 70 billion requests a day. That's clearly not one machine. That's a cluster of machines. But that's pretty ridiculous. So that should tell you how chatty DNS servers tend to be. If you want to have fun and figure this out for your own, you should go through the pains of installing X11 and Wireshark on your Macs in the correct order, and then turn on Wireshark. X11 first, Wireshark after, otherwise you have to do it twice. So if you turn on Wireshark and listen to UDP port 53, that's your DNS conversation, you're going to have a moment of panic and enlightenment and be like, oh my god, everybody knows everything all the time. So, DNS. Cool. So because they have so many requests and they have to do so many things, DNSs also have to be really fast. So on average, the Google public DNS responds in about 45 milliseconds. It's actually much faster because it gets to do a lot of caching, and we'll talk about that one in a second. But yeah, 45 milliseconds, that's not that much for resolving an IP. Just for bragging rights, CatDNS responds to everything in 7 milliseconds, but keep in mind it only knows cats. So, you know, YOLO. Cool. So we kind of know what a DNS is now, yeah? We're comfortable with that? At the top level, the way this conversation works between your browser and the DNS system is that your browser is going to want some sort of, and it doesn't have to be your browser, it can be an application, but let's say it's your browser. It's going to want to, oh no, that's going to be tragic. Can I make this smaller? So at the top it says images.google.com in that pink box you can clearly see. So it's going to ask a DNS server, and the DNS server is going to respond with two pieces of information, the IP and the TTL. Ignore the TTL for a second. It's the time to live of that record. I'm going to go into it in painful detail. But basically, that's the only thing the DNS does. You give it a URL that you care about, a host name, and it tells you what the IP of that host name is and how long it's valid for. The way it actually works, like behind the scenes, is that this first DNS that you're calling is actually called a recursive name server. The reason why it's called a recursive name server is that it actually doesn't know any of the answers out there, but it knows who to ask and how to fetch that information for you. So it's kind of like a really dumb server, but it just does a lot of work for you, and that's why it's really good. So the first thing the recursive name server is going to do is ask something called a root name server. So the root name server sort of sits on top of the internet. It's actually the dot after .com, because a host name actually looks like images.google.com dot, sort of ends in a dot, and that's the root name server. So the root name server knows everything about the top level domains. So it knows about the name servers for .com, for .org, or things like that. Trivia time, because it's 9:30 in the morning. There are 13 root servers in total. They're lettered A through M. They're not actually 13 machines. They're backed by about like 380 redundant servers. But the reason for that is actually really hilarious and sad at the same time. So a UDP message for DNS can be 512 bytes. That's it. That's its like maximum length, which means if you take away the header and all that stuff, you can fit 13 IPs. That's all the root name servers you're ever going to get. Congratulations. 2014. So yeah, so the root name server is going to be like, I personally don't know anything about images.google.com, but I see you're asking about a .com thing, so why don't you go and ask the .com server? So the recursive name server is going to do this again, but with a .com server, because it was so exciting the first time. So it's going to ask the .com server about images.google.com. You still have not gotten everything. You're getting hungry here. And the .com server, again, just knows about things directly below it. So it knows about google.com, yahoo.com, Monica's cats.com. So it's going to tell you it doesn't know about images.google.com, but probably google.com might. So finally, a recursive name server goes to google.com. Thankfully, you have found an answer. Google.com is authoritative about this. So the moment a DNS server knows how to respond to a question without having to do any work for it, we say that it's authoritative. So you can say that a root name server is authoritative about the .com name server, if that's the thing you're asking it about. Google.com is authoritative about images.google.com. The reason why this is important is that an authoritative answer is kind of a special thing. It's like you got it right this time. You didn't pick it up from a cache and it might be a crappy answer. And it's going to return to you the IP, and then we can finally give it back to your browser, and oh my goodness, you can finally look at some cats. Please keep in mind, this was just to load images.google.com, not actually the cats on images.google.com. So, whew, this was a lot of work. This doesn't actually ever happen because it would take 4 hours for you to see any cats. And that's because we actually cache a lot of things. Everybody caches all the time. So your recursive name server caches every question that it gets asked. So if I ask it for images.google.com, if I ask it for images.google.com a second time, it's going to be like, hold on, I remember this. You already asked me. Here's your IP. We don't have to do any work. 1 millisecond response time. On top of that, there's things like the root DNS address or the .com DNS address or the google.com DNS addresses. It stores all of those intermediate steps too, so that if you can skip ahead anywhere in that host name, it's going to, because this is what makes the internet fast. On top of this, oh yeah, no. So the reason why this works is because of the TTL. So remember, I told you your DNS server returns two things, the IP of that host name and a TTL. TTL stands for time to live, and it's the bane of every web developer's existence. And it basically tells you how long a name record can live before it starts growing mold on it, and you need to get it again. Things like Google.com, the website, have a TTL of about 5 minutes. I'm going to show you, I think, some TTLs in a couple of slides, so I don't have any spoilers here. If you get whatever your domain registrar is or your hosting, it might let you set your TTL for your host. And you can be a bit of a jerk and set it to like 1 millisecond, or in the assumption that if it's like 1 millisecond, it's never going to go wrong. But keep in mind, you're making the internet slower as doing that. So unless you think your blog is always going to change its IP, put a civilized DNS, civilized TTL. On top of that, your browser also caches a lot of things. So I only know things about Chrome because I'm a Chrome developer. Angelina can tell you things about Firefox. I'm sure Firefox does this too. But Chrome caches a lot of your DNS requests because if the DNS wants to be fast and minimize the amount of work the DNS server does, the browser wants to talk to the DNS server as little as it possibly can. So for example, when you're loading a page and you figure out like the IP for that page the first time, for any of the relative resources, you're not going to have to re-resolve that, because you're going to cache that IP for a little bit. And if you go to Chrome Net Internals DNS, you're going to see this page. So this is, Chrome's going to tell you the things that it has cached. It caches a lot of like the ad domains and stuff like that, like the double click, because nobody wants to resolve those all the time. You can also see things like expired. So that's because the TTL has gone stale, and that's no longer a potentially correct record. And you can always clear it. The reason why I'm saying clearing is important, because 90% of the time, the only reason why you care about the TTL is because you've changed your hosting and nothing works anymore. You've waited an hour and it works on your computer. It doesn't work on anybody's computer. You're like, oh my goodness, what have I done wrong? This is because of TTL, and this is called DNS propagation. So it's very likely that my computer is connected to a different ISP than your computer. So we're probably using different DNS caches. We probably have different browser caches. So it's very likely that my record will expire before your record will expire. So you need to wait for a little bit for everybody's computer around the world to expire their particular DNS record. There's a neat website called whatsmydns.net, which is kind of a lifesaver. So it basically hits like 50 or 70 DNS servers around the world, and you can see how far along your new IP has propagated, your new DNS record. So that's kind of fun if you have any debugging problems. You know that overused joke that sometimes parents are going to tell you when they find out you're a programmer, with like, oh, there's 2 hard things in computer science, naming things, cache invalidation, and off by 1 errors, ha ha ha, it's hilarious. Turns out cache invalidation is a real thing, you guys. It's hard. So now that we know that every DNS has a cache, we can screw up with that cache a lot, and this is what malware things do. And this is called cache poisoning. So remember this little dance that we were doing before, where your recursive name server was looking for this authoritative name server to get an answer from. We'll say that somehow we managed to hack into the .com name server and convince the .com server that we're really authoritative about Google.com things. We're a Google.com DNS, but we're actually like a malware DNS. We're lying. So instead of returning the actual IP of images.google.com, I'm going to return to you the IP of my really crappy service that is going to install things on your computer, because that's what I should do. And I'm going to return it with a giant TTL, so that something like 10,000 minutes, so that it stays in your cache forever and ever, and your DNS never has to clear it, because that's what malware things do. This is called cache poisoning. It's really fun. I'm not going to tell you how to fix it, because it's also really hard. But you should go read about it on Wikipedia. You're going to get a headache. Basically, don't try to actually write a DNS server, is what I'm trying to tell you here. It's hard. Cool. Cache poisoning. All right. So now we know how to, all of these are my cats, by the way. It's either pictures of my cats or pictures of my friends' cats, because if you have cats available, you shouldn't look for them on the internet. Cool. So we know how to talk to a DNS server. We know what the DNS server does. So your next step should be, I should read the RFC if I want to implement my own DNS server, right? Nope. The DNS RFC was written in 1997, which was particularly pedantic here, in my opinion. So the RFC is like 100 pages long. It's written in Courier-New. It doesn't have any like pagination that's really civilized. It's really like tedious and pedantic. It sort of makes you feel bad as a person, because you're like, I don't understand half of the words you're saying. And it doesn't actually help you understand what DNS does, or particularly how to parse that message either. So good news, we've got tools. Tools can do this for us. We don't need to read words. We're programmers. It's going to be great. This is my favorite slide. if your cat's a DNS server. Your cat should not be a DNS server. Cats are useless at DNS. First and simplest tool ever is Nslookup. Nslookup does exactly that, looks at name server record for you. In its simplest case, Nslookup Google.ca, oh no, this is tragic. Oh, it's not that tragic, I'm joking, it's really not that tragic. I think I'll live. Nslookup.google.ca is going to return to you a bunch of IPs for Google.ca. You're going to see that it says non-authoritative answer. This should not surprise you, because remember, we're hitting a recursive name server. That one's not authoritative about anything. It's probably getting it from a cache. So we're getting a whole bunch of IPs. Beautiful. The much more interesting example is if you look up something like nodwaldorf or github.io, so that's where my blog is hosted, because I'm really lazy and I don't pay for hosting. I use GitHub's. And if I try to look up that one, I get something really weird about canonical names, and it tells me it's actually a canonical name for a generic Fastly net that doesn't have anything about nodwaldorf. That's terrible. And it gives me an IP, and if I put that IP into the browser, I'm going to get a 404 page. That's what we call a shared IP. So shared IPs are really fun because prior to IPv6 and also IPv6, we only have a certain number of IPs available for everyone. And we don't want to give them to every 14-year-old who wants to hold a blog about Justin Bieber, because that would be a waste of an IP. So what hosting companies tend to do is that their giant server has an IP, and their giant server knows how to redirect you to the correct page based on what your HTTP request has. So this is why if you make a plain HTTP request to 199. The thing that you can't see, you're not going to get anything. But if you make an interesting HTTP request that has, by the way, I'm looking for nodwaldorf's blog, you're going to get that. Shared IPs. The reason why this is relevant is that if you're writing a CatDNS that should always return to you the IP of a thing that gives you cats, that IP has to be static, because you're going to get HTTP requests from all sorts of websites, like Google.com and Twitter.com, and they're probably not going to know that they have to tell you things about where the cats live. So cats have to be a static IP cat. My favorite tool in the universe, and this is really disturbing because I have a giant crush on a tool called Dig. Dig stands for Domain Information Groper, which is a little terrifying, and I think it was also written in the 80s when this was a cool thing to do. So Dig is amazing and hilarious. If you just do dig.google.ca, you actually get the entire DNS response, and this is awesome, because that's why you don't have to read the RFC. So every query and every response in DNS pretty much look the same, only a response has extra fields and some different things in the header. So this is what the header looks like. And the things that change, here you can see it's a query, and you've got 4 answers, and it's non-authoritative. These are things that we already know. Sometimes you're going to get errors in there if you're asking for a name record that doesn't actually exist anywhere. That's fun, that's a header. Then comes the question section. So the answer is going to echo this question section so that you know you're answering to the right thing. And the question section has 3 things in it. The thing that you're asking for. Also, note, see how it ends in a dot? That's for the root server thing. And then it's going to ask for in, which stands for internet. Another option is chaos, which I genuinely don't know what it means, but I think it's amazing, but nobody uses it. Chaos, I want to ask for chaos. And A, which stands for name record. It stands for address record. You can also ask for things like a certificate or a CNAME. So that's what that value would be. And then comes the answer section, which basically for the thing that you've asked in the question section, you add 2 fields. What are those fields? I told you like 4 times, the TTL and the IP. That's it. That's genuinely the entire DNS conversation. That's it. Pretty awesome. This is why writing a DNS server is kind of easy. Dig gets really fun if you start passing it parameters. So trace is a really fun parameter that's actually going to, rather than just go to your DNS server and ask it for a question, is going to go to all of the DNS servers in that little dance that I show you. So it's going to ask the root server for the .com, and the .com for the google.com, and the google.com for images.google.com. So it's going to do that entire dance. And that's how you can figure out what the DNS is doing behind the back. And on top of that, you can actually tell it what DNS server you want to be talking to. So in this particular case, I'm talking to 8888 because it wasn't my default DNS. But if you want to skip ahead, you could, for example, query the google.com DNS about images.google.com directly. So you're going to skip all those first steps. And this is what I promised you I was going to show you about TTLs. So the root name server has about a 4-hour TTL. Root name servers are also the ones that get hacked the most. So this is why you don't want to give them like 4.5 weeks for a TTL, because that might screw up the internet. Things like the .com and the google.com DNS servers have a pretty giant TTL. They're about 48 hours, and that's because they generally don't change. Like if you see the google.com one points to ns1 and ns2.google.com, it's very likely they're always going to point to that. So they can be comfortable with a pretty big TTL. And then the next thing that you actually get isn't directly the images.google.com IP. You get the fact that it's a CNAME for images.l.google.com. CNAME basically is a fancy word for an alias. And the reason why you would want to have a CNAME like this is that you can imagine different websites or different services pointing to the same IP. So I can have images.google.com and cats.google.com and Monica's amazing DNS cats.google.com all pointing to the same thing, which should just be images.google.com. So you want to give it a CNAME so that I don't have to change this IP in 70 billion times if I ever have to change it. CNAMEs are great. And then you get the actual IP of that, which is less interesting. Diga's the greatest. You should go home and play with it. It's already installed on your Mac. If your DNS server is running OpenDNS, trace might not actually do anything for no reason that I understand, so that's a thing. Cool. So because it's 9:30, I should show you some code, because I know that's exactly what you want to look at. So CatDNS is written in Node because somebody on Hacker News told me this would make me more metal, and I'm a C++ developer, so I really want to be metal, because I'm never going to be metal with C++. So it's written in Node. Also, at the time, I didn't know how to write a server and anything else without hating myself, so cool. It uses 4 amazing packages. Dgram, which is the thing that makes a UDP socket. Buffer, it's the thing that comes down the UDP socket. IP is a neat little thing that converts from a string representation of an IP to the long representation of it, because that's what you want to shove down the DNS message. And bit array is, wait for it, an array of bits. That's how you parse the header. I think CatDNS has like 60 lines of code, and 90% of them are me trying to parse the DNS message in a really crappy way with like string concatenation, because it was really late at night, and yeah. So the first thing you need to do is create a socket on port 53. Port 53 is a small port, and if you ever see a port that is that small, you probably need to be sudo for it. So you should, if you do, I strongly recommend you fork this, and you should run it, so you should sudo that. Cool. And then every time you get a message, things happen. First thing you do is you're going to parse the message. This is going to be painful. It's going to make you hate yourself for a little bit. It's going to take days. But once you figure that one out, you're going to make a response. This is also going to make you hate yourself a little bit because you need to flip some endians around, and you're not going to think about that. But it works. Once you figure that out, you're going to shove the IP of the cat service or Imgur. Hold on to this thought for a second. You're going to laugh to yourself because you're like, oh my god, I'm going to return cats to google.com. This is the greatest. And then you're going to send the cats down. That's it. You've written a DNS server. Everybody should pat yourself on the back. This is it. C++ developers can do it. Let's talk about Imgur. So I told you that CatDNS sends you to an IP, which is a web service that gets a cat from Reddit and displays to you this cat. This is excellent, but if every time I see a host name, I always redirect it to the CatDNS IP, that means that when I'm trying to actually display that image of a cat, I'm going to get into this vicious thing where it's like, oh, it lives on Imgur, but I don't know what Imgur is, so I should take you back to the CatDNS service, who's going to be like, oh, I should display you a cat. I don't know where that cat is. I should take you back to the CatDNS service. This means that the CatDNS Go service needs to know about Imgur and needs to be able to correctly resolve Imgur so that you can actually get a cat. If you don't pronounce Imgur, Imgur, I'm sorry. I also pronounce it GIF, not GIF. These are things I've never gotten right. Or the Doge. I think I mispronounced Doge, too. So yeah, CatDNS is actually authoritative about cats and everything on Imgur, which is great, because you can just go and look at dogs if you want to. We're not discriminating. We know about DNSs. What should we do with all this knowledge that we've acquired now? First thing, keep in mind that if your DNS is slow, this means that all of your internet is slow. Everything that's happening on your computer has to go through that DNS server. If you're using a terrible DNS server, everything will be terrible. You're not going to get any cats. You want to get cats. This is the problem we're trying to solve. So if you're suspicious your DNS server is terrible, you can pick a faster one. You can try the Google public DNS and see if that improves your experience or not. You can also host your own if you want. I don't recommend writing your own because that is insane. Unless it serves cats, that is awesome. But if you want to hold a legitimate DNS server that actually does work and takes you to the website you're actually asking for, Bind is an open source DNS server that you can just like spawn up on a server and just make it go. If you're also paranoid about privacy, that's also a thing, because keep in mind DNS knows everything that you're doing on that computer, so maybe you're concerned about those things. DNS is really fun because you can get around geolocation. So a couple months ago in Turkey, the ISPs were blocking things like Facebook and Twitter and things like that, and the reason why they could do it is because as an ISP you have a DNS server, all the traffic goes to you, so you can just choose not to resolve those particular host names. So what everybody started doing is using a different, using Google's public DNS, which doesn't care where you're making this request from, so geolocation is no longer a thing. It can also help you with Netflix if you're in Canada. ask me about that later. You can fork, hi internet, I didn't say that, please don't come and after me for that. You can fork CatDNS, and the best part about forking CatDNS is you can run it and put it on your router, and then open your Wi-Fi and just like let your neighbors connect to it, and instead of getting to Google.com, they're gonna get cats, and that's gonna be hilarious for everybody. Thank you.